All right, 2.6 day 2. Today we're going to talk about composite functions. So we're going to form composite functions, we're going to determine domains for composite functions, and we're going to write functions as compositions. So the composition of functions, it says the composition of the function f with g is denoted by, notice it looks like it's an f with a little open circle between them and then g. And is defined as f composed of g with respect to x, which is the same thing as just saying f of g of x. And so we've done this before, we just didn't formally label it. All right, so I'm going to use this slide just to help us. So if I'd have told us like f of x equals x plus 4. And if I told you to find f of 4, you would have just plugged it in. So 4 plus 4, you would say is 8. But if I told you to find f of x plus 1, you'd done the same thing, you'd have just plugged in the x plus 1. So you'd have said, well, it was x plus 4, we plugged in the x plus 1, and then we would have simplified it. So x plus 1 plus 4, which would have gave us x plus 5. Okay, that's the same thing as what we're doing today. The difference is, like on that last part that I just did there, I'm going to tell you f of x is x plus 4, and I'm going to tell you that g of x is x plus 1. And I want you to find f composed of g of x. So that means we're going to take this g of x and we're going to plug it into that f function. Okay, so the f is my skeleton. This is on the outside. G is on the inside, so this is what we're going to plug in. Alright, so if f is my skeleton, it's x plus 4. We're going to plug in that x plus 1. Well, wait, isn't that the same exact thing I have written like right there? It is, because we're doing the same thing. We're just writing it formally, okay? So we could have went ahead and worked it out from there. If we work this out, we'd have got x plus 1 plus 4, which is still the x plus 5 that we got in our final answer from before. All right, so we already know how to do it. We're just plugging things into an equation, but now we have a setup where it looks like, we're plugging in one equation into another. All right, so that's what we're talking about, just the composition of functions. So stuff we've done. The difference is when it comes to the domain. Okay, so the domain, it tells us that x is going to has to be in the domain of g, and then g of x has to be in the domain of f. The easy way to do this is to find the domain. We're going to find the domain of the input, which is what we're putting in to the equation, so that's what we're plugging in. We're going to find the domain of the output. So that's our answer, whatever we get when we do it. And then we combine the two domains. And once we do that, we will get the domain of our composition. All right, so example 1 says we have f of x equals 5x plus 6 and g of x equals 2x squared minus x minus 1. Find f composed of g with respect to x. All right, so remember, this is just notation, okay? This is just saying, hey, x is going to be the variable, and this is just saying we're going to combine the two with f being first. It's on the outside. It's our skeleton. All right, so most of the time you'll see me write it like this. So we're going to take f, which is our skeleton, which remember means that we're going to write it without the x. We're going to put parentheses there. Now notice that g of x is kind of a longer problem, so I'm going to put a little bit bigger parenthesis. Okay, so it's my 5x plus 6. And then remember what's on the inside here tells us what we're going to plug in. So we're going to plug in g of x, which is 2x squared minus x minus 1. And then we just simplify that. So distribute the 5. And then combine like terms and make sure you write it in descending order of the exponents. And so they were already in descending order. Just combine the negative 5 plus 6, and we got 1. All right, now what if on this, instead of saying g of x was 2x squared minus x minus 1, what if we'd have said, well, our f of x, let's keep it the same, so 5x plus 6. And let's well, you know what, let's keep g of x the same actually too. Yeah, let's do that, so I don't have to rewrite all this. All right, but what if I asked you for f of g of 4? Now it's different because I put a number inside there, okay? So what you're going to do there is you got to take the 4 and plug it into the g function. So we're going to go find g of 4 first. And so it was 2x squared minus x minus 1. Because remember, what's on the outside is my skeleton. And we're going to plug 4 into this. And then we're going to work it out. So I have 2 times 4 squared is 16. Minus 4 minus 1. So 32 minus 4 minus 1. 28 minus 1. So we get 27 as our answer, okay? But now that's just for the g of 4. So now they're saying, okay, well this is 27, so this means I'm really looking for f of 27. So once you find the answer to g of that 4, you're going to go plug that back into your f function. So now we're looking for f of 27. Well, f now is my skeleton. Okay, so it's 5x, doesn't need to be that big this time, plus 6, plug in your 27, and then work it out. That's what I think, 135, yeah, and then plus 6. So work that out, we get 141, and that would be our final answer, okay? So notice, when we put a number in, we got a number out as our answer. On the previous one we had done here, we plugged in something with an x. I'm so sorry. And so we get something with x with our answer. All right, and then it's just talking about the domain again, which we already talked about earlier. Remember, take the domain of the input, the domain of the output, and then can put them together. All right, so here it says it wants us to find the composition of f composed of g with respect to x if f of x is 4 over x plus 2 and g of x is 1 over x. So we're looking for f composed of g of x, which remember means f is my skeleton. So we have 4 over x plus 2. And we're going to plug in g of x, which is just 1 over x. Well, the problem we have now is we have a fraction within a fraction. But if I had not put that fraction right there in there, everything would be good. If it had just been a 2x, we would be okay with it. But it's not. But we do know how to get rid of that fraction. How can I get rid of that little fraction there? How can I get rid of the little x in the denominator? Well, just like what we've always done, we want to get rid of a fraction, we multiply by the denominator. But what we do to one term, we have to do to all terms. So on top, we get 4x over, on bottom, we get 1 plus 2x. Now, we can't factor this. We can't cancel anything. So that's going to be our answer. Then the next slide wants us to find its domain. So let's see, we know we're going to have to find the domain of the input. And what did we input? That was the 1 over x. We got to find the domain of the output. Which is the 4x over 1 plus 2x. And then we're going to combine the two. I'm going to put combine previous to. All right, so the domain of the input, we said it was 1 over x. Remember, it is a fraction. So therefore we know that the denominator cannot equal 0. So that means that x cannot equal 0. Now, if I had anything to solve, move around, I would. But I don't. It's just already solved for x. So this is going to be part of that restriction, okay? So I'm going to come over underneath where it says combine the previous two, and I'm going to write x cannot equal 0 there. Now, for the domain of the output, again, we can see it's a fraction. So we know our denominator, that 1 plus 2x cannot equal 0. And this one's just not x equals, or x is not equal to, so we got to solve it. So we got 2x cannot equal negative 1. Divide by 2. And so we know x cannot equal negative 1/2. So that's also going to help me find it. So I'm going to come over here to combine the previous two. I'll put x cannot equal negative 1/2. Okay, so to actually find their domain, we're going to put those two together here. And so if I look at my number line, we have our infinities. We know x cannot equal 0. X cannot equal negative 1/2. Make sure they're numerical order. We know it can't equal them, which means it can equal everything else. And so there we have our intervals. We have the negative infinity to negative 1/2 union. We have negative 1/2 to 0 union, and then our 0 to infinity. And so that would be the domain of this problem. Then they want us to switch it up. Now they've given us this composition, and they want us to write what the two functions are, okay? So in order to do that, the first thing we're going to do is we need to find x. Then we're going to let the expression with x equal our g of x. Alright, so what that looks like so far. Now we got more steps, but just so far. So I see that x is right here, but I see its expression is all of the whole thing underneath there. So our g of x is going to equal the x squared plus 5. Alright, then we're going to put an x over the expression that is equal to the g of x. So I'm going to come up here with my problem, and I said g of x was x squared plus 5, so where's the x squared plus 5? I'm going to put a big x over it. Not the square root piece, because it doesn't have a square root in g of x, okay? Just the x squared plus 5 gets x'd out. Alright, so f of x will equal whatever is written now, or whatever is left. How about that? So when we look at this, then we can say, okay, well, f of x is equal to what is left. We still have our square root symbol, so the square root, and then the only thing we have underneath it now is that x that we wrote there. So f of x will equal the square root of x. And so these two would be our solutions there. Now you can check it. You can find the composition. If you do f composed of g of x, remember f is your skeleton, so square root of x, and plug in the g of x, which is the x squared plus 5. Is that the problem we started out with at the top? It was. It was the original problem, so therefore we know that we did it correct.